Welcome to doassignment-ca. Here is the problem. Two cars start from rest side by side and travel along a straight road. Car A accelerates at 4 meters per second squared for 10 seconds and then maintains a constant speed. Car B accelerates at 5 meters per second squared until reaching a constant speed of 25 meters per second and then maintains this speed. Construct the acceleration time, velocity time, and position time graphs for each car until t equals 15 seconds. What is the distance between the two cars when t equals 15 seconds? Now let us work through the solution step by step. Car A starts from rest and accelerates at 4 meters per second squared for 10 seconds, reaching 40 meters per second. After that, it travels at constant speed until 15 seconds. On the acceleration time graph, Car A shows a flat line at 4 from 0 to 10 seconds, then drops to 0. Car B accelerates at 5 meters per second squared. Dividing 25 meters per second by 5 gives 5 seconds to reach top speed. After 5 seconds, Car B cruises at a constant 25 meters per second. On the acceleration time graph, Car B shows a flat line at 5 from 0 to 5 seconds, then 0. The velocity time graph for Car A rises linearly from 0 to 40 meters per second over 10 seconds, then stays flat at 40. Car B rises linearly from 0 to 25 meters per second over 5 seconds, then stays flat at 25. Notice that Car B reaches its top speed earlier, but that speed is lower than Car A's final speed. The distance for Car A is found from the area under its velocity time curve. During the first 10 seconds, the area is a triangle. 1/2 times 10 times 40 equals 200 meters. From 10 to 15 seconds, the area is a rectangle. 40 times 5 equals 200 meters. Total distance for Car A at 15 seconds is 400 meters. For Car B, the triangular area from 0 to 5 seconds is 1/2 times 5 times 25, which is 62.5 meters. From 5 to 15 seconds, the rectangular area is 25 times 10, which is 250 meters. Total distance for Car B at 15 seconds is 312.5 meters. The position time equations are parabolas during acceleration and straight lines at constant speed. At 5 seconds, Car B is actually ahead of Car A. By 10 seconds, Car A overtakes Car B, and the gap continues to grow because Car A's constant speed of 40 meters per second is greater than Car B's constant speed of 25 meters per second. Subtracting Car B's position from Car A's position, 400 minus 312.5 equals 87.5 meters. So at 15 seconds, Car A is 87.5 meters ahead of Car B. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.